Hello friends, welcome to AS Education. In the last videos we have seen the projection of planes, projection of solids, and in this video we are going to start the section of solids. So in the section of solids we are going to cut the solids by particular plane. That plane is called AIP, auxiliary inclined plane. Generally when we are going to cut that solid in front view, this AIP is supposed to be normal to the vertical plane, and when you will be cutting this solid in the top view, that is supposed to be normal to horizontal plane. So after cutting this solid, we are going to get the front view and top view. At the same time, the way it got cut by AIP, the section can be appeared. That section must be having a true shape. That true shape is supposed to be drawn separately. Apart from these three views, we are supposed to develop the lateral surface of this solid, whether it is a prism, cylinder, cone or pyramid. We are supposed to open that lateral surface and develop it. The way it got cut on its surface, that cutting line should be visible in that developed surface. So friends, let's move to the problem directly. Here you can see a hexagonal prism is given, which is having 30 mm base side and 60 mm axis standing on HP on its base, whose one side is parallel to VP. Now friends, very first thing, this hexagonal prism is standing on HP. It means the hexagon you are going to get in the top view. So you should start with the hexagon in the top view, where one of its side is parallel to VP. This way you are supposed to draw its top view, and then correspondingly you are going to draw its projection in front view. Then it is being cut by a section plane which is inclined at 45 degree to HP, and it is passing through the midpoint of the axis. So it is cut by some inclined plane, and then you are supposed to draw its front view, sectional top view, the true shape of the section and the developed surface. So first of all, we will try to see how this solid is being cut with this auxiliary inclined plane, and also lastly we'll see how that section can be seen as a true shape and as an apparent shape. As per the problem, the prism is kept on HP, so its hexagon, that is the base, can be seen in the top view, but it should be in such a way that one of its side must be parallel to vertical plane. That way you are supposed to draw the hexagon in the top view, and once it is drawn, then apparently you can take projections in the vertical plane. That would be your front view. So this would be your front view, this would be your top view. And as per the given problem, this solid is being cut by a plane which is passing through the midpoint of the axis, and it is making angle 45 degree with HP. So let's see how this solid is being cut by that plane. So friends, here you can see the auxiliary inclined plane which is passing through the midpoint of the axis line, and it is making angle 45 degree with horizontal plane, and also it is normal to vertical plane. So let's cut this solid with the help of this auxiliary inclined plane to get the section surface on this solid. So after being cut with the help of this AIP, the front view can be seen like that, the retaining part of this solid like that. And once you are going to view this object from the top, it can be seen as what? The regular hexagon. But this section is not the regular hexagon because it is inclined surface. So to get the true shape, we must look in the perpendicular direction, not from the top. When you will be looking from the perpendicular direction to this surface, so you will be getting the exact true shape of this section. So in our problem, we are supposed to draw the true shape of the section and also the development of this surface. We will start the problem using AutoCAD, how we can develop this true shape and development of this surface. So friends, very first of all, we will draw the XY line, and then using the continuous layer, we will draw the hexagon in the top view. Go to the polygon, give number of sides as 6, enter, do right click click on edge, click any one point, drag the mouse, give distance as 30 and enter. I'll just move this just downside this XY line, and then I'll name these points. Then we'll name these points 1, 2, 3 and all. Now once we get the hexagon in the top view, to get the front view, we'll take projections vertically upward in the front view. So as it is a prism, we are going to get the rectangle in the front view, which is having axis as 70 mm. So I'll change layer to the projection layer. Just draw the line till this XY line. We'll take projections of all these points till this XY line first. And now we'll draw the rectangle of 60 mm height. So make ortho mode on, give 60, enter. I'm drawing this front view in projection layer because once you are going to cut this prism, the removing part should be in the projection lines, while the other part, the retaining part, should be drawn in the dark lines. So initially I am drawing this whole object in projection layer. Now at the same time we need to draw the axis line as well. So you can show the center line and you can just draw the midpoint to midpoint because that would be the axis line. You can adjust the scale of this line using LTS command. So now the similar naming can be given on the front view as well. So friends, once you identify all these vertical edges by taking projection from the top view, like this 1 is projected as 1 dash in the front view, 2 and 6 as 2 dash and 6 dash, 3 and 5 are projected as 3 dash and 5 dash, and 4 is projected as 4 dash. Now it's time to draw this auxiliary inclined plane, that is a plane by which you are going to cut the solid. It is inclined at 45 degree with HP and it is passing through the midpoint. So we'll take line command with the help of center line, and from the midpoint of the line we'll start drawing a line which will be at an angle of 45 degree. So we'll extend the line on right hand side, press tab key, give angle 45, then enter, escape. Now you can extend the same line in downward direction in the same direction itself. So friends, this is the line through which the solid is being cut. So now the retaining part is supposed to be drawn in the dark line. So just complete it by dark line over here. Now once this solid is being cut with the help of this section plane or AIP, on this surface you are going to get the section and you are supposed to name those section points. So I'll start with this point itself, as this is passing through exactly corner point, and this is what only one vertical edge is there at point 1. So here also only one point would come. So I'll give here naming as A dash. So friends, after cutting this solid through this AIP, we are supposed to name all these points on this surface one by one. When it is cutting this vertical edge, there are two vertical edges, 2 dash and 6 dash. So there should be two naming should be there at this point. So I'll name this point as B dash and C dash. Then this cutting plane is cutting this vertical edge, which are again 2 in number, 3 dash and 5 dash. So again there are two namings would be there at this point. So I just name this point as D dash and E dash. Similarly, this cutting plane is passing through the corner point which is present on this vertical edge itself. So again single point will come over here. So I name this point as point F dash. Now these are the points which are present on this surface of cutting plane. So once you are going to project all these points vertically downwards in top view, you know that A dash will come exactly at point 1, B dash and E dash which are present on vertical edges 2 dash and 6 dash. So these 2 points will come at point 2 and 6. D dash and E dash which are present on 3 dash and 5 dash, that will come exactly at point 3 and 5. And F dash which is also present on 4 dash, that will come exactly on 4 dash. So just give naming of all these points in vertically downwards in the top view. So just name all these points of this section in the top view as well. So friends, the way you are having different points on this section plane in the front view, you are supposed to project all these points vertically downwards in the top view as well. So I'm getting the namings as A, B, C, D, E and F in the top view as well. So as an observer, when you will be looking from the top, you can see here the whole solid is being cut from the top. So all over the surface from the top, you can see the hatching lines. So go to the hatch command, choose ANSI 31 and click the area where you want to show hatching. If you want to increase the scale, you can increase from 1 to 1.5 and then close it. Once it is done, now we have completed the front view and the top view. Now we'll see how the true shape of the section can be drawn, because whatever the section we are getting in the top view, it is not the true shape. When you will be looking from the top, it is just apparent shape you are getting of the section. To get the true shape of the section, we are supposed to look at the section in the perpendicular direction. So once you are going to look in the perpendicular direction, you will be getting the true shape, for which I will be copying this line at some random distance to draw the true shape. When I am copying this line at some random distance, it means I have drawn a line parallel to this line itself. Now using projection layer, just draw the projection from each and every point till this center line. Take projection layer, line command. From each and every point on this section, draw a line which must be perpendicular to the second center line. This way, you can draw the projection line from each and every point on this center line. So friends, once you draw the projection line, we are supposed to show the true shape of the section on the opposite side of the center line, for which these projection lines are supposed to be extended beyond the center line. But the distances we are going to take from the top view. So we'll go to the dimension. From this XY line, we'll take a distance of point A. That is what vertical distance we want. That is 51.22. So take projection layer again, and from this line, draw the line in the same direction. That distance must be 51.22 and press enter. Similarly, when you are looking for the dimension of point C from this XY line, it is getting 25.24. So I'll change the layer to the projection layer again, line command, extend the same line in the same direction and give distance 25.24, press enter, then escape. In the same line, you are going to get that point B, which will be at a distance of from XY line, we are getting the distance as 77.2. So using projection layer, we'll draw another line from this point onwards that will measure 77.2 and then enter. So there are 2 points now here. So friends, whatever the distance we have calculated for point A from XY line, same distance will be there for point F, and same distance for point C and B will be applicable for D and E also. So we can copy these lines from these 2 points to these 2 points. Once it is done, go to the continuous layer, take line command. From this end point to end point, draw a line. Again between these 2 end points, draw another line. Then to the last point over here. Now while connecting line from this point to another point, the end point should get catch. So make sure that in object snap mode all points are selected, then only this end point selected. Then click the second end point over here and come to the original point. So this way we have just drawn the true shape of the section when you will be looking in the perpendicular direction to the surface. Now this section is supposed to be shown in hatching lines all over its surface. Go to the ANSI 31 and select the region. Then close it. These dimensions are not required, so just delete them. And here you can name the true shape of this section. So this is what the true shape of the section. So friends, this is all about drawing front view, sectional top view, and the true shape of this section. Now we will see how the lateral surface can be developed. So this is like what we are considering. This is hollow surface, and once it is opened, all the cutting edges should be visible on that surface itself. Now to get the developed surface, we'll just copy this vertical edge of the prism from point 1, and at some random distance we'll place this line on XY line itself. Now the height of the developed surface would be same as that of what? The prism, but the length would be what? It would be exactly equal to perimeter of this prism. So that is what 30 mm is the side of the base multiplied by 6. So it is 180 would be the total length of the developed surface. So I'll give here length as 180. That is the perimeter of this hexagon. That is 180. Enter. The total height is 60. Make ortho mode on. Height 60. Enter. And connect with this endpoint. Now you know that at every 30 mm distance, the vertical edges can be seen. So just copy this first line at a distance of 30 mm each. 30, enter, 60, enter, 90, enter, 120, enter, 150, enter. So at 30 mm distance, you can see the vertical edges on this developed surface of the prism. You can give dimension of this developed surface as 180. Now friends, this is what we have drawn developed surface in projection layer, because we want to show the only retaining part of the solid. The removed part should not be shown in the diagram. So that can be shown with the help of projection layer only. So we'll try to project all these points of the section on this developed surface. Before that, we must recognize these vertical edges in terms of their names, like 1 dash, 2 dash, up to 6 dash. So I'm just naming these points. So friends, here we have just identified all these vertical edges. Now we'll be projecting all these points of the section respectively on their vertical edges. Like A dash is coming on 1 dash. So we are projecting point A exactly at point 1 and 1. Here we are supposed to draw all the projection lines which will be originating from all these points on this developed surface. So take projection layer and through every point draw the projection lines on this developed surface. A dash is lying on XY line only. So now we'll be recognize all these points one by one. Point A dash is lying on vertical edge 1 and XY line. So point A should come exactly on vertical edge 1 and XY line. So I'll draw the point here. So friends, I just projected point A dash on vertical edge 1 dash, that is on 1 we are getting point A. Similarly, we can see vertical edge 1 is present on end also, because we have opened the solid from one vertical edge, so that edge can be seen on both sides. So we got point A on vertical edge 1. Then it's time to project B dash and C dash, which is coming on 2 and 6. So on this projection line, on vertical edge 2 we'll get B, and on 6 we are getting C. So we are getting point B and C respectively on vertical edge 2 and 6. Now D dash and E dash are coming on 3 dash and 5 dash. So after D and E, it's time to get point F, which is exactly on point 4 at the top base. So point 4 on the top base, at this point we'll get point F. So here we get point F. So once you project this point F on this developed surface, we get point F on vertical edge 4 and on the top base. Now once you get all these points, join all these points with the help of straight lines. Because it is a prism, we'll be connecting these points with the help of straight lines. If it is a cylinder or cone, in that case, we are supposed to join all these points with smooth curve. But whenever it is prism and pyramid, we will be joining these points with straight lines. Go to the line and start joining all these points by straight line. After joining all these points, this is the retaining part, so that's why I've drawn the bottom line, and the upper part is supposed to be removed. So this part should not be darkened. So in these vertical edges which are beyond this cutting plane or AIP, those must be dark here. Here in the front view also, these vertical edges must be dark beyond this cutting plane. So similar kind of vertical edges beyond this inclined plane should be dark here. So take line command and draw these vertical edges from the respective points on below line. So friends, that's all about section of solids and development of lateral surface of prism. In the next video, we'll see how a pyramid is cut and how to develop its lateral surface. So friends, thank you very much, and I hope you understood this concept of section of solids and development of lateral surface. Thank you so much for watching. I hope you understood all these concepts regarding this section of solids and development of lateral surface.